Good morning to everyone. My name is Borgarino, and I'm the tutor of Antonio Ricciardi, which is not here because he is spending an internship at the last CNRS laboratories in Toulouse, France. The main research activity carried out by Antonio is relating to custom integrated circuits for automotive applications. Several chips were developed or investigated during this last year, in particular addressing several applications, also in the automotive applications. Transmitter front-end for parsed ultra-wideband. This was a chip designed in the last year and was tested and successfully tested, and this chip is in fact working. Then a receiver front-end for global navigation satellite system has been designed. The work is of course in progress because the chip is very large, and during this year just a fraction of this chip has been designed. Then in the frame of a national project, it is started the investigation of a chip for the diagnostic tool for SCMT, which is an acronym, it is an Italian acronym standing for Stato Controllo Moto Treno, which is a control very useful to test if the train is running or not. Finally, this is the project for which Antonio today is not here, but is in France. It is a France national project, which name is FINEST. In French means Fonction Intégrée Fortement Équilibrée pour Système de Télécommunications en Bande Millimétrique. And in fact, Antonio now is designing a down mixer where the input frequency is 80 gigahertz and the output frequency is 1 gigahertz. In fact, it is a very challenging circuit. We'll see. In short, concerning the ultra-wideband transmitter, in the last year, the work started from the system requirements, and in this year, the chip was tested, and here you can see the spectrum of the pulse generated by the chip. In fact, it is working. And this project was carried out in collaboration with a design center located in Bologna. And now the chip is practically a final product that will be inserted in the tire of the vehicle to transmit between tire and electronics in the car information like pressure, speed, and so on. Concerning the global navigation satellite systems, here just a slide to remind some basic information. The chip will work in the 4 band here indicated like E5, A, and so on, which are located in the radio navigation satellite services and the aeronautical radio navigation services band. And even if these bands are were originally used for navigation services and aeronautical services, are now planned also to be used for cars. Here you can see the receiver working with specification from the Galileo transmission system, and as usually the design of the chip starts from the system requirements. Then these specifications are broken down to electrical specification useful to design the circuits. And here we see the building blocks of the chip used to carry out system simulations. Here we have a snapshot of the circuit designed by Antonio. It is a VGA, voltage gain amplifier. And this chip is based on the design of GM cells and will be used inside this AGC loop in order to keep constant the amplitude of the signal. These are, of course, only simulation results because the chip is, the design chip is in progress, and we will see the next year the results obtained from test. Again, here we have just a snapshot, just a brief reminder of the SCMT application. The chip will be used in the management of the rail traffic on the rail network, on the Italian rail network. The project is just starts from a few months, so the work is really in progress from the beginning. And here we see which is the main part designed, even if just at the beginning by Antonio. And it is a circulator realized not with magnetic non-linear material, but realized with integrated electronics, just in order to save space and to give the possibility to integrate all the systems in a single small chip. And this is the French project sponsored by the RNRT, Réseau National Research and Telecom, which is a research network on electronics and telecommunication in France. And in particular, this project is in the field of the millimeter wave integrated circuits, integrated microelectronics, which is a very hot topic today in the international scientific community. Here we have the schematic, just the principle of the schematic, basic schematic of the down conversion mixer. It is a passive mixer because the frequency is very high. So in this case, the main attention is devoted to conversion function rather than gain. So the main objective, the main goal is to get at the output the desired 1 GHz frequency without introducing amplification in the mixer in itself. These are the early simulations carried out in France, where we can see that the voltage gain that we have a voltage conversion gain, which is not a power gain, because the power gain is related to voltage gain through impedances, which is not here still specified. And another point very important to underline is that also another important point is the linearity. Here we have the number of the output intercept point at the output. This is just a slide to shortly summarize the activity carried out by Antonio. Which is most important in my mind to underline is that with the experience carried out by Antonio in collaboration with companies in Italy and with research laboratory in France, we have maybe the possibility to organize or to participate in the future to a European project. I mean that this is a very important goal, I believe, for our school, because if we are able to grow a network of research in Europe, thanks to the work of our PhD students, maybe in the future we can gain more possibility to get more PhD students, more funds, and so on. Well, thank you to all for their attention.